Sample 140 on superposition. Determine the vertical reactions at B and C by the superposition method. Moment of inertia of portion AB is I, and for portion BC it's 2I. So here's the given figure. So I want you to have presence of mind, and let's transmit the effect of the 20 kilonewton load. 16 times 3 is 48, so we change this loading into 48 at the end C. Then 16 times 3 times 1.5. 16 times 3 is 48 times 1.5. We have 72 kilonewton clockwise couple as shown. Then for portion AB, you have to transmit 20, and the couple is 20 times 5, 100. Then we have 48 also. And this is the couple 72. Couple which is 48 times 7, so 336. Then 20 times 5, 100 couple. 20 times 5. Then the 24 kilonewton load. And here we have R sub C. Then here we have R sub B. Then R sub C times 7, we have a couple also of 7 R sub C. R sub C and 7 R sub C. So I hope that without the details, we can still manage to analyze the total effect, total deflections at C due to the reactions, and total deflection at C due to the loads, as well as at B. So EI delta CR is equal to 7 R sub C 7 square over moment of inertia 2, 1 plus 2. Let's compute for the deflection here. So the moment at this wall is 7 R sub C, so it will deflect up. Then the length is 7, so 7 square. The moment of inertia of portion BC is 2. The moment diagram by parts, the degree of the moment diagram for R sub C is 1, then plus 2. That's the formula. Then plus 6 times R sub B plus R sub C, 6 square. This will deflect upward, and it will also contribute to delta C first degree plus 2, because the moment of inertia here is just I. Then for this couple, 7 R sub C 6 square over 0 degree plus 2. Then because there is slope at the end, and it is 7 of the whatever the slope here due to these effects, so we have 7 times 6 times R sub B plus R sub C times 6 over 1 plus 1. Then the effect here is 7 of this couple, so 7 times 7 R sub C times 6 over 0 plus 1. So simplifying, AI delta CR equals 340 R sub C over 6. This one is 72 R sub B plus 72 R sub C. Here we have 126 R sub C. Here we have 126 R sub B plus 126 R sub C. And for this last term, 294 R sub C. Combining like terms, so EI delta CR equals 4051 R sub C over 6 plus 198 R sub B. Next, for the effect of the loading. So we have at C. So let's begin with this. The moment at this wall is due to the effect of the 48 kilonewton load is 48 times 7. Then the length is 7 square. This will deflect downward. That's why the deflection is preceded with negative sign. Then moment of inertia 2, degree 1 plus 2. Then for the effect of the 72 kilonewton couple, 72 times 7 square over 2, 0 plus 2. For the effect of the 20 kilonewton load, 20 times 5 is 100, or 20 times 5 times 5 square over moment of inertia 2, 1 plus 2. Then this will deflect down because of the slope here. So 2 theta, 2 times 20 times 5 times 5 over moment of inertia 2, 1 plus 1. So everything is accounted for this part. Now let's have the accounting for this portion here, which contributes deflection at C also. So plus 68 times 6, 68 is 48 plus 20, that's 68. The moment here at the wall is 68 times 6. The length is 6 square over 1 degree plus 2. Then the effect of these three couples, 72, 336, 48 times 7, 36, and 20 times 5, 100. So that would be, by the way, this is 7 times theta due to the 68 kilonewton load. So it will deflect further by 7 theta at C, 7 theta at B rather. So 7 times 68 times 6, that's the moment. Then the length is 6 over 1 plus 1. Then plus the effect of these three couples, deflection at C. So the total magnitude of the couple is 72 plus 336 plus 100, that's 508. 6 square over 0 plus 2. Then 7 theta of contribution of the slope of these couples. So 7 times 5 or 8 times 6 over 0 plus 1. That's the contribution at C. Then the contribution of this 24 kilonewton load, the moment is 24 times 4 times 2. So it will deflect down, which contributes to deflection at C. So 24 times 4 times 2 times 4 square, the length, over 2 plus 2, degree plus 2. Then because there is slope here, and the distance 2 plus 5 plus 2 is 9, so 9 times 24 times 4 times 2, 4 over 2 plus 1, its contribution here. So combining, negative EI delta C is 2744 plus this one is 882. This term is 1250 over 3 plus this term 250 plus this term 4896 plus this term 8568 plus this term 9144 plus this term 21336 plus this term 768 plus last term 2304. So combining, EI delta C is negative 153926 over 3. Then at B, so the first equation therefore is 4051 R sub C over 6 plus 198 RB equals 153926 over 3. Call that equation 1. Then for the deflection at B due to the reactions, so we have 6 times quantity R sub C, EI delta BR equals quantity 6 times R sub B plus R sub C, 6 square over 1 plus 2. Then the contribution of this couple, 7 R sub C times 6 square over 0 plus 2. So that's only it for the deflection at B. Simplifying, AI delta BR equals 198 RC plus 72 RB. So for the effect of the loadings, let's begin with this 68 here. 68 times 6, 6 square over 1 plus 2. Deflection is downward. Then for these three couples combined, 508 times 6 square over 0 plus 2. Then for this 24 kilonewton meter load, the moment is 24 times 4 times 2 times 4 square. The moment is 24 times 4 times 2, 192 times 4 square over second degree plus 2. Then because there is slope here, we add 2 theta. So 2 times 192 times 4 over 2 plus 1. And that's only it. So combining AI delta B equals negative 15320. So the second equation is 198 R sub C plus 72 R sub B equals 15320. Solving these two equations simultaneously, we get R sub C 70.245 kilonewtons and R sub B equals 19.604 kilonewtons. So if you want to compute for reaction at A, you just apply statics, and for the moment reactions at A, you also apply statics. But in this problem, we are just required to determine the vertical reactions at B and C. So that's enough. So I hope you are able to follow. If you want to solve it again so that you can understand the each term in these calculations, I want you to draw the deflected shape so that you can analyze and be able to follow the presentation of these terms so that everything will be accounted for. But later on, when we discuss three moment equations, slope deflection equations, then it's better to analyze these problems using those methods as well as the moment distribution method, so that we can have a shorter way and the proper way of analyzing continuous beams or statically indeterminate structures.